In this section, we're going to take a look at an introduction to unit testing. Our videos are going to cover JUnit syntax and JUnit classes, some annotations, setup and teardown, and then we're going to write some sample, simple JUnit tests. So first of all, let's talk about JUnit syntax and classes. In JUnit, we have things called fixtures, test suites, test runners, and test classes. A fixture has any prerequisite setup and teardown for running tests. A lot of times if we want to put some prerequisites together, like open a connection to a JSON feed or something like that, and we want to do this in multiple tests, we'll do it in a class called a fixture. But we also want to keep in mind that our unit tests should really just be testing one unit of code at a time. So instead of opening a bunch of prerequisites, we might want to take a look at mocking objects. We'll take a look at mocking objects with Mockito in a later section. Now we have test suites that will aggregate tests together so that we can run them all at once. This is a good idea if we want to test all of our DAOs, or maybe test our service layer and our DAO together. We can use a test suite to do this all at once. Now we have also a class called test runner, which will run our JUnit tests. In Android, this might be handy if we have a script that runs our tests, but to be honest, a lot of running the test is built into Android Studio automatically. All we need to do is right-click and say run. So some of these classes we'd use in a standard JUnit test, but aren't as necessary in an Android JUnit test. Then we finally have the JUnit test classes where we are writing our tests. This is where we're saying we want to verify that our tests pass. So an assert is going to be important here because an assert is where we say this is what we expect to be true. For example, an expected value equals an actual value, or a Boolean value is true, or an object is null, or an object is not null, one of those things. And then we have a test case, which is where we define the test that we want to run. Now in JUnit 3 we would extend a test case class, but in JUnit 4 with annotations it's not as necessary. We can use annotations to determine which tests we want to run. And then finally a test result class will aggregate together the result of running tests. So test case, we have setup and teardown methods, but here again we'll see that we can do this with before and after annotations, and also before class and after class annotations, which we're going to discover in the next video. That being said, a lot of times we will still name a method setup and teardown, and we'll simply annotate it with the before test and after test, or before and after class, because those are the methods that we're used to seeing from JUnit 3. There are several other methods that are not as frequently used on test case, which are fairly self-explanatory: run, get and set name, create result, and count test cases. So we'll take a look at an example here in just a moment. Our next video is going to look at annotations in more depth, but we'll just kind of take a preview of that right now. We already have our layers set up from a previous video, so we're going to jump right into the test directory here. Remember, that's where we put any standard unit tests that don't require the Android framework. I'm going to choose new in Java class, and I'm going to call this test plant DAO. Now I don't need to extend anything because this is JUnit 4, and the test plant DAO naming convention is kind of a throwback to JUnit 3, where we had to actually use the word test in the class name. We don't still need to do that, but for history's sake, oftentimes we do. Also, it's descriptive. It tells us what we are testing. So I say yes, check this into version control. Now in true test first design, we want to write the test first before we've even written the code. I'm going to take some liberties here. I'm going to write a test against the stub that I created a few videos ago, just so that we can get a little bit of satisfaction in watching a sample unit test work. So first of all, let's make a new method. Let's say test plant DAO, and then we'll say search for redbud should return at least one result. Note that it's a very long method name, and that's very much on purpose. Also, I need to say public void, because the method name should adequately describe what the test is doing. Now, I need a couple of annotations, so I'm going to say @test up above. That's going to tell me that this is a method that is running a unit test. You see, as soon as I do that, Android Studio is smart enough to give me a couple of play buttons here, which will allow me to play either all tests in this class or just this one test method, which is quite nice. Also, I can create a public void setup method where I do any kind of initialization, and I can annotate that with the before method, before annotation rather. The setup method was common in JUnit 3. We don't need to use that same syntax anymore of calling it setup. We just need to have that @before annotation. We'll talk a lot more about annotations in our next video. So I have my two testing methods. Now what I'm going to do is I'm going to create a reference to the class that I am testing. I'm going to say iPlantDAO, plant DAO. We're simply going to define a variable for the DAO we are testing. In the setup method then, I can say plant DAO equals new plant DAO. Now see, this is how we would typically write a test first design test, is actually we would call a constructor of a class that does not yet exist. And step number 1 would be to create that class after we write our unit test, where the unit test tells us what we want to do. But again, in this video, in this specific video, we just want to take a look at some unit test syntax. So I'm going to go ahead and fill this in with the stub that we created in a prior video. Okay, now in our test method, what I'm going to do is I'm going to say plant DAO.fetchPlants, and we're going to pass in the string redbud. Okay? In Android Studio, Control-Alt and V, if I have my cursor on a method, Control-Alt and V will look at the return type of that method and assign that to a new local variable. And we see, sure enough, it assigns it to a new local variable. We'll choose the name plants. And what's really nice about that Control-Alt-V is it knows what type this method returns. So it knows that fetchPlants returns a list of plant DTOs. And it's smart enough to figure that out for us. That's going to save us a lot of time. Now what we can do is we can put together a for-each method. A for-each method is going to take a look at a collection, something that implements the iterable interface, which in this case, list iterates iterable. So it's going to take a look at that collection, and it's going to basically shake hands with each item in that collection. So I put the collection on the right side of the colon. On the left side of the colon, I put the type of the object that is in that collection. So plant DTO, plant, plants, means I'm going to shake hands with everybody in this plants collection, and each time I iterate, I'm going to take one item, I'm going to put it into a variable called plant. Now within my for loop, I can say if plant.get, let's say get common, and then we can say contains, and then we can say redbud. Then we're going to call this success. Okay, it might be better to actually look at the genus as well. A redbud, all redbuds are in the genus Cercis, so really a better test might be to look at the genus as an attribute, maybe even the species Canadensis, but we're going for simplicity here. We're just taking a look at the syntax of a unit test. Now, what do I mean by success? Well, this is a little bit interesting because our requirement is that we have at least one matching result. So let's start by assuming we do not have a match. And I'm going to make a Boolean variable, and we'll say redbud found equals false. Okay, and then if we find a redbud, we're simply going to flip that switch to true. Redbud found equals true. And then after the iteration is over, we're going to say assert true, and then we're going to say redbud found, like so. Okay, assert true requires that we handle some imports here, just like so. Okay, and we'll say did we find a redbud. Now in a later video, we'll take a look at a more modern way that we can do asserts with something called Hamcrest. This assert true syntax is something that we see a lot in JUnit 3 and 4. It's kind of like a second generation of asserts. We're now on to even a third generation, which is called a Hamcrest style assert, which certainly is supported in Android Studio, as we'll see in a future video. But at this point, we have enough at least to verify that our unit test will run. I click on the Run Test button, just like so, to run the single method. It's using a built-in JUnit runner. You notice I didn't really have to do anything magic to get this to run as a unit test. So I have my annotation. I'll tell you what, it didn't like that, did it? Test plant DAO. Okay. I have my assert true. I'm going to go ahead and run it the old-fashioned way. I'm going to right-click and choose Run. And sure enough, when we run like so, we see that we do get a successful result, one test pass. Just to make sure that it didn't dummy something up, I could put some garbage in here, and I could run it one more time. Okay. And this should say, okay, it didn't work because I just put garbage data and nothing matched that. Let me go ahead and set it back to Redbud, and just to be sure, run it one more time, and we choose Run. And everything should pass. And sure enough, we pass. Okay. We see that now my individual run just this test passes. I suspect it had a little hiccup there earlier just because it hadn't done a full build, but after we ran the full test, now it's happy to just run this one method individually or the entire class itself and give me results. We see that we got success because we got a green bar, and when we get a green bar, the correct thing to do is smile because our unit test is passed, which indicates that the code we have written is quality code as well. So in our next video, we'll take a deeper dive look at annotations. I look forward to seeing you then. Thank you. In this video, we're going to take a look at annotations that are used in JUnit. So we'll look at test and ignore, which are both used to run or ignore tests, and then some of the setup and teardown methods, and then also how to run with a certain suite of tests or run with some parameters. So @test is probably the most common and also the most important. It indicates that this method should be evaluated by JUnit. This came to us new in JUnit 4. Prior to JUnit 4 and JUnit 3, our tests were run based on naming conventions, so we had to have the word test in the method name. But in JUnit 4, you can simply add that @test annotation to any method, and it will be considered for a JUnit run. So very frequently used. There are a couple of annotations that we can add to the annotation, for lack of a better word, or perhaps properties is better. First of all, @test timeout equals and then a number of milliseconds means this test, if it processes longer than that number of milliseconds, we're going to consider it a failure. So maybe something that requires a network connection or something that requires a test completed within a certain amount of time, that's when we'll use this timeout mechanism. The other one that we have is sometimes we run a test and we want to verify that an exception is thrown. For example, if we're testing a DAO method and we don't hear back from the network layer, we want to confirm that we haven't heard back from the network layer via an exception. And then we can make a decision on what to do based on that exception. A side note on that, exceptions are very powerful in Java. A lot of people don't like them because they have to deal with a try-catch block or something like that. But really, a checked exception, which requires that you have a try-catch block or you rethrow the exception, makes you stop and think, how am I going to handle an adverse scenario? How do I handle a scenario where the network is not available? And this is something that we want to think about. When do we throw back a checked exception, or when do we not throw back an exception? So @test, with this property expected equals, and then in this case I've said class cast exception, means that the test will pass if we receive this class cast exception. It will fail if not. So a lot of good things we can do to the test annotation. Now let's say that we are doing our test first design as we should. we're towards the end of a sprint, and one feature is not going to get finished in this sprint, so we're going to push it off till the next sprint. We've agreed with the product owner, we're going to delay this until the next sprint. The problem is we have already written our test first design classes for this feature that's not complete, and our build won't finish unless all of the tests pass. What we might do in that case is put the @ignore annotation above a test class, and that says, okay, ignore this one for the moment. Now, we should only use this temporarily. Obviously, we don't want to write a test that permanently gets ignored. But in the case where we're pushing a story from one sprint to another and the tests don't pass and we want to finish a build for the current sprint, that's where we might use this @ignore. Now, in JUnit 3, we had the setup and teardown methods. In JUnit 4, we can do a lot of this with annotation. So @before means this will run once before each test, and that @before goes on a method. @before class means this will run once for all tests, so it'll only run one time, and then we run all test methods. And then similar, they have counterparts in the after category. So @after means we run this after every single test. @after class means we run it once after all tests have finished. So @before will be good for anything where we need to do some initialization, and then @after is good where we need to deinitialize things or reclaim memory, close a database connection, anything like that. So similar to the setup and teardown methods of the past. Now, a lot of times we want to run tests together, so we use this @runWith and @suite annotation. Let me start with @suite. @suite says @suite.suite classes, and then you see an open paren, open and close curly. In between that open and close curly, we'll have a comma-separated list of classes that we want to run together. So that says, let's run these all in one go. We kind of categorize them, put them into a compartment. Now, what we'll have in addition to that is @runWithSuite.class, which says, I want to run this test, all of these tests together, okay? The other way that we can use @runWith is with something called parameterized, which is really neat because we can pass in some parameters and run some data-driven unit tests. Maybe instead of just test for redbud, we'll test for redbud, we'll also test for white maple, maybe bur oak, something like that. We'll run the same test against a set of predetermined data. So these are annotations. These are something that greatly extend the flexibility of JUnit, make our test less dependent on superclasses, more like POJOs. In the next video, we're going to see an example with some of the setup and teardown annotations, in other words, @before and @after. I look forward to seeing you then. In this video, we're going to take a look at sample JUnit test with setup and teardown. Now we already have an example unit test that we can work with, and with this unit test we have one test and one before annotation. I'm going to add a few more annotations here to show before class, after, and after class. Not all of these will be functional, but they will be demonstrations of how we can use these annotations. So first, @before class will run only one time before all of the unit tests run. It has to be static. So let's make it public static void, and we'll say set up all tests. And in this one, we'll just do a simple system out print line. Now, I typically do not recommend system out print lines, especially in Android. Logging is much better, but in this case, it's going to give us a good idea so we can see when these annotations run. So running, let's say, I'll tell you what we'll say, before class, running init for all tests. Now our existing setup method, we'll extend this a little bit, and we'll simply say SOUT again. And this one we already have, we'll say before, running init before each test. Okay, and now let's do some afters. So I'm going to say @after, and after is going to run after every single test. So we're going to say public void teardown. That's the classic JUnit 3 style name for this method. And again, nothing really to say here, so I'm simply going to say system out print line, tear after, and then tearing down each method, each test rather is probably better. And then we'll also do a tear down all classes, so after class. That's going to run only one time after all of our test methods have run. Because it runs only once, it needs to be static as well. If you don't recall what static is, that means we do not need an object to run this method. We just need a reference to the class itself. In other words, it's not altering any attributes of an object. So tear down all tests. Method name doesn't matter as long as we have the annotation. System out print line, and then we'll say after class, finalizing, or let's say tearing down after all tests. Now, why would we use that tear down method? If we had to do something like disconnect from a database or network connection, it would be best to do that in a tear down, in other words, in an at after or at after class, depending on how many tests are using this resource. Additionally, we might have a test that changes something external. We hope not to do that. We hope to mock out our objects, but that scenario might happen. If that scenario does happen, then an after can revert whatever we've changed back to its original form so that the next test will run correctly. If you're getting a sequence number out of a database or something like that, you might use the after to say, okay, now revert that back to its original form, because the next test might have a prerequisite that the sequence number starts at 0, something like that. Let's add a system out print line to our existing test method. Okay, so we'll say running, we'll say test, running redbud test. Okay, and this example is only really going to show well if we have more than one test. So I'm going to duplicate our existing test, and I'm going to change it to search for white oak should return at least one white oak. Or let's say search for oak should return at least one white oak. Let me change the internals of this, so white oak found. Okay, list plants, search for plants, and we'll say oak. And then if the common contains white, something like that. Or we could even say if the genus equals, ignore case, Quercus, and then we could use the and symbol to say and plant dot get species contains alba. That's the scientific name for a white oak, Quercus alba. Then we say white oak found equals true, and then assert true, white oak found. Okay, and then test running white oak test. Now, I know this is going to fail because we're going against our stub data, and our stub data right now only has a nasturtium and a redbud. So this one's definitely going to fail, but that's okay. All we want to do is verify the sequence of the before class, before test, after class, and after methods. As a matter of fact, let's do one more. Let's say that we want to count the number of results for a very broad query. So maybe I'll say public void test plant DAO search for E should return at least 2 results. So if we just search for the letter E, we should have at least 2 results. We should have quite a few. Because remember, we're doing just a contains search. Now, note that I have intentionally left off the @test annotation because I want to show that when we run this as a test, this method is not going to run because it is missing the @test annotation. So plant DAO, and then we'll say fetch plants, and we'll give it the simple letter E. Okay, and it of course doesn't really matter because it's not going to run anyway. Control-Alt-V will take this return and assign it to a local variable. Okay, and then we can say plants dot, let's say size. Okay, and we'll say, let's see, we'll do a Control-Alt-V, and we'll say and size equals plant size, and then we'll say, this is where a ham crest style assert really works better because we can do is greater than. We haven't talked about hamcrest just yet, but let me just go ahead and give you a taste of what's coming. Assert that is what we use for our hamcrest, and we start with size, and then we say is, and then we could say greater than, and then 2, something like that. So it's not going to run here purely because this whole method's not going to run. So actually, let me go ahead and do something a little more simple, just because for hamcrest I have to pull in a few extra dependencies. We'll just do a simple size greater than 2. We'll say boolean at least 2 equals size greater than 2. Then assert true at least 2. Okay, so we'll make it a little bit simpler, but yeah, a hamcrest assert would work much better if we're doing a greater than or less than comparison like this. Also, hamcrest asserts are going to work a lot better with collections. They have some frameworks, some libraries that make it a lot easier to test collections. But that's not the point of this video. We will have another video that will discuss this. We just want to show test. This should not run because it is not annotated. Okay, and save. And now let's go back and run our test. Just a moment. And we'll go back so we can run it. Okay. And of course, we want to make sure we save and test. And we're really more interested in the output here. So let's go ahead and run. And let's pay close attention to the output. Okay. So we see before class running init for all tests before running for each test. Then we have a redbud test. Then tearing down each test as an after. Let me expand this just a bit so we can see the whole thing. And then after tearing down each test, okay, now we have our assertion failed error, and then we have our after class tearing down all tests. So you see the before class was the very first thing to run, and it only ran one time. The after class was the very last thing to run, and it only ran one time. Okay, the before ran before each test, before our redbud test, and before our oak test, which ultimately failed. And the after ran after each test, after the redbud test, and after the oak test, which again ultimately failed. We don't have a message from the oak test because frankly it failed. It didn't even get there. But more importantly, we don't have a message for the search for E should return at least 2 results. We don't have our this should not run message because that's not properly annotated. Therefore, it didn't run. So that's a look at some of the annotations we use in a typical JUnit test. The other annotations that we see, like at run with, at suite, and at rule, we're going to see those as we get into more advanced testing where we're doing things like using at rule to get a reference of the current activity, and then we're using at run with to say we want to use an Android JUnit test runner, and we're using the at suite annotation so that we can put a bunch of tests together in a suite and then have that entire suite run automatically every time we run or emulate our program. So this video doesn't look at that, but not to worry, we are going to have future videos that look at those other annotations, and they're going to play a very important role in our test first design framework. So this has been a look at a lot of those annotations, and our next video we're going to look at test-driven design and how to design for test. I look forward to seeing you then.